Hey, this is Jeff Trotman for Circlebox. If you work with computers long enough, eventually you're going to need to know how binary, or base 2, and hexadecimal, or base 16 work. We're so used to counting in base 10 that we don't really give it much thought of how that works. But if you think of how these clicker counters work, each wheel has got 10 digits on it, and when I advance the last digit all the way back to its initial point, back to 0, it's going to take the next digit with it.
So to demonstrate this, I need a base 5 counter, but it's a lot easier to write a simulation on a computer than it is to buy or manufacture one of those counters with different numbers of digits on each wheel. So right now, when this is set to base 10, this works just like the regular counter does. I get to 9, it rolls over to 10, exactly like we're used to counting. Each wheel has got 10 digits, 0 to 9. Now I'm going to change it to base 5. So this is going to simulate where I've got 4 wheels, but each wheel only has 5 digits, 0 to 4. As I click, it counts up. So far, it's like we expected, but 4 is our highest digit in a base 5 system. So now when I click, it's going to roll over to 1, 0. Not 10, 1, 0. And again, 4 is the highest digit. So when a digit rolls over, it's going to take the next highest digit to the left and take it with it. So base 5 is not very commonly used. Base 2 we use in computers all the time. In base 2, we've got 2 digits, 0 and 1. We count up like this. And then we're out of digits, and we start back at 0, just like the counter does. If I get to 9999 and click the button, it's going to roll over to 0. Now, if I go to base 16, we need more digits because each wheel needs to have 16 digits on it, and we've only got 10 that we're used to, 0 to 9. So we're going to say that our additional 6 digits are A, B, C, D, E, and F. So it's going to look like this. When I get to 9, the next digit is not going to, the next wheel is not going to increase because I'm not out of digits yet. When I get to F, which represents 15, now it's going to roll over. The URL to this simulator is in the notes. It's available on the internet. You're welcome to log in and play with it. Computers think in binary, which means we have sequences of binary digits like this. This is hard for humans to process and to think about. Instead, if you'll group it into 4-digit groups like this, we can then easily translate that into a hex pattern like this using this mapping. So 1011 in binary equals B. B is the equivalent of 11, remember. A is 10, B is 11, C is 12, D is 13, E is 14, F is 15. 1001 is 9, 1100 is C, and you get the idea. For humans, it's a lot easier to deal with this hex shorthand, and that's why hex is valuable for people that work with computers.